Hello and welcome. This lecture will be about the Babylonian and the Mayan numeration systems. So we're going to first talk about the Babylonian numeration system. The way it works is similar to ours in that it uses place values, meaning depending on where the symbols are, they're worth different amounts. So, like in our system, we know that 102 is not the same thing as 201. But the way that this works is within each place value, you add the numbers. So, if I just had Babylonian numerals like this all together, I would add these up as 10, 10, and 3, and that would be 23. So within place values, add. Also, place values are designated by a space. So if I had something like this, I would read that as having 3 place values, and it helps to just draw boxes around them. Okay, so let's say we want to convert this Babylonian numeral into Hindu-Arabic. How are we going to do that? Well, what we first want to do is determine how many place values we have, 3 of them, and then write what each place value actually has. So the first one would be 20 and 5, second one would be 31, and finally 1. What are these place values? Look down at this part, which is on your formula sheet. We have place values of 1s, 60s, 3600s, and the same way that we did before in the 6.3 and converting the bases, we're doing the same thing here. Like we have 25 $1 bills, so that's $25. We have 31 $60 bills. Which is 1,860. And then one $3,600 bill, 3,600. Add them all together, and we get 5,485. It's important to note that these place values aren't as crazy as they might seem. We deal with this every day, actually. Like, this could represent seconds. There's 60 seconds in a minute, and then 60 minutes in an hour. So in that regard, we do use remnants of the Babylonian system in our everyday life. If we want to go backwards, it's the same idea as before. The same way going forwards, we need to multiply and add. Going backwards, we need to divide and subtract. So we look on the bottom here to figure out what are we dividing into first, or how many place values do we even have. So look over here to see the highest number without going over. That would be 3,600. So I know my answer, my final answer, will have 3 spots, 3 place values. The 1s, 60s, and the 3600s. So I want to know how many times does 3,600 go into 8,503? We divide. And we get 2 point something, but the important one is it's 2, meaning a 2 goes here. 2 times 3,600 is 7,200. We subtract, and we have remainder 1,303. And now we want to know how many 60s go into that. Okay, 21. Again, it's 21 point something. 21 times 60, you get 1,260. Subtract off. And we have remainder 43. By the way, so how many 60s do we need? 21. And then finally, for completion's sake, I want to know how many 1s go into 43, with course 43, with remainder 0. Alright, our final step then is to convert all of these numbers into Babylonian numerals. So 2 would be written as just 2 daggers, and 21 would be 2 arrows and 1 dagger. And then 43 would be 4 arrows and 3 daggers. And then that's it. That's our final answer. Okay, so moving on. The Mayan system. They also use place values, although you'll notice it's not in any particular base. It's not really base 20, and it's not really base 18. It's somewhere in between. In either case, the numerals, I mean, they're all laid out here and they're on your formula sheet, but honestly, you can look at it as a dot is 1, a line is 5. It's an easier way of remembering it. But we're going to proceed the same way. The one thing to note, though, is that the numbers are written vertically, with the greatest place value being up top and the least being on the bottom. So, the 1s. So, in this example, we have 3 place values. So we work at it the same way that we did with the Babylonian system. I want to write it out what those numbers actually are. So that's 10, that's 8, and the next one is 11. Again, what are our place values? Well, they're over here. Start at the 1s and go up. 1s, 20s, 360s, okay, so again, same idea, we multiply across, 10 times 360 is 3,600. 8 times 20 is 160. And 11 times 1 is 11. Add everything up, and we should get 3,771. Okay, let's do one more example like that. Now we have 4 place values. And it's the same process. We have 5, 0, 11, no, sorry, 12, and 3. And again, our place values go from the lowest is your 1s on the bottom, 20s, 360s, and then 700 or 7,200. So we end up getting 3, 240, 0, and 36,000. And you add these all up, and we get 36,243. Finally, let's go the other way. It's the same idea as the Babylonian though. We want to know, first of all, how many place values do we even have? So look over here to see what's the highest number without going over 7,495. And so it's this guy, meaning we're going to have 4 places. So I might as well write them on the side. And also write what they mean so I remember where these things go. Okay, so I want to know how many 7,200s go into 7,495. It goes in ones. And we have remainder 295. Now I want to know how many 360s go into 295. Well, none. And so we still have remainder 295. Now I want to know how many 20s go into 295. So 14. And we get 14 times 20 is 280. Subtract that, we get 15. And finally, for completion's sake, how many ones go into 15? 15. Okay, and our last step is rewriting this with the Babylonian numerals. So 1 would just be a dot, the 0 would be the turtle shell or the eye, depending on what it looks like to you. And 14 would be 2 lines and 4 dots. And 15 would just be 3 lines. And then that's it. We're done.